NASA astronaut Megan McArthur, as they have worked throughout the course of the overnight hours to help prepare Thomas Pesquet of the European Space Agency, who's on the right side of your screen, and hidden from view at the moment, Shane Kimbrough on the left side of your screen, helping them to suit up in their U.S. extravehicular mobility units. They are in the equipment lock section of the two-compartment Quest airlock, ready to begin what is expected to be a 6.5 to 7 hour spacewalk to install new solar arrays called iROSAs. You'll hear that term referred to throughout the course of our coverage today. iROSA, the acronym for ISS Roll-Out Solar Arrays. These new arrays are designed not to replace the legacy or older solar array wings on the station, but rather augment their power capability for the rest of the lifetime of the International Space Station. Today's spacewalk will be the 239th spacewalk in support of ISS assembly, maintenance, and upgrades, the 7th spacewalk to be conducted out of the International Space Station this year, the 7th spacewalk in the career of Shane Kimbrough, who has accrued a total of 39 hours even on 6 previous spacewalks. He will be wearing a helmet camera bearing the number 22 during the course of today's spacewalk. Helmet camera number 22, and this will be the 3rd spacewalk in the career of Thomas Pesquet, a former Air France pilot who is with the European Space Agency making his 2nd flight into space. His 2 previous spacewalks accrued a total of 12 hours and 32 minutes of spacewalking time. He'll be wearing a helmet camera bearing the number 20 during today's spacewalk. The 2 crew members will also be wearing HD helmet cameras, as well as the standard helmet cameras that you have become familiar with over the course of spacewalking coverage. That will provide more detailed looks from the crew members' perspective as they conduct all of their activities in support of today's spacewalk. The Orbit 1 team of flight controllers is on console at this hour as you look at an overhead view looking at Shane Kimbrough, who is again on the left side of the Quest airlock's equipment lock section, just over the shoulder of Thomas Pesquet, who's on the right side of your screen, lower right-hand side of your screen. They suited up with the assistance of Mark Vande Hei, NASA astronaut, and Megan McArthur earlier in the morning. Megan McArthur will be operating the Canadarm2, the space station's robotic arm, to transfer Thomas Pesquet, who will haul these new first set of iROSA solar arrays toward the on the far left side of the truss of the International Space Station. Today's work site managed by Flight Director Ron Spencer. We'll be hearing the voice of Canadian Space Agency astronaut Jenny Sidey, who will be the so-called ground IV captain, or essentially the spacewalk choreographer, who will be discussing all of the procedures step by step with Pesquet and Kimbrough while they conduct their work outside of the Quest airlock. The crew inside the Quest's equipment lock has been breathing oxygen and conducting light exercise to increase their metabolic rate and increase the dispersion of oxygen out of their bloodstreams to prevent any condition known as the Benz decompression sickness from occurring when they step out into the vacuum of space. Today's spacewalk is scheduled to begin about an hour and a half from now at 7 a.m. Central Time, 8 a.m. Eastern Time. A U.S.-based spacewalk out of the Quest airlock is measured at the beginning from the time that the crew switches their suits to internal battery power until the time of repressurization when they're back inside the airlock at the completion of an EVA. The first pair of these new ISS Roll-Out Solar Arrays were delivered to the International Space Station just a week and a half ago with the arrival of the Space Cargo Dragon vehicle that launched on a Falcon 9 rocket from the Kennedy Space Center in Florida. These rollout solar arrays, again, do not replace the current sets of solar arrays, but rather augment the power capability of the solar arrays. The iROSAs basically are an innovative new solar array design that uses high-strain one-piece carbon fiber composite booms. The stored of the booms, they're rolled up, provides the actuation for their deployment once a series of bolts are released by the two International Space Station. The two crew members will be working out at the P6 truss. This was the first truss segment and the first set of solar arrays that were delivered to the International Space Station aboard the Space Shuttle Endeavour in December of 2000 on the STS-97 mission that was commanded by former astronaut Brent Jett. In the forthcoming months, two additional pairs of iROSA solar arrays will be delivered. The next pair will be installed on the P4 and S4 starboard 4 truss of the station, and the final pair will be deployed on the S or starboard 6 truss and the starboard 4 truss. 6 of the 8 power channels for the International Space Station will have their power augmented by these new solar arrays. The current solar array wings, the huge wings that you see, there are 8 of them on the station, 2 for each of the photovoltaic power channels on the station. Each of the old legacy solar arrays have 32,800 solar cells total, assembled into 164 solar panels, the largest arrays ever designed and deployed in space to convert solar energy into electrical power. The normal electrical power output for each solar array wing at the beginning of its lifetime was 31 kilowatts, for a total of some 248 kilowatts of total power. These new solar arrays, the iROSAs, that will be installed for 6 of the 8 power channels, are designed to provide an additional 20 kilowatts of electricity, eventually totaling some 120 kilowatts in all of augmented power during orbital daytime. In addition, the remaining uncovered solar array pair and partially uncovered original arrays will continue to generate some 95 kilowatts of power, for a total of some 215 kilowatts of power for the rest of the lifetime of the International Space Station. This will accommodate more modules to be launched to the International Outpost and to provide the augmented power to the 6 power channels that have, through normal wear and tear over more than 2 decades of use, have seen some degradation in power output. This will bring the International Space Station back to an even more robust power capability than the original arrays were designed to provide. Kimbrough and Pesquet, interestingly enough, conducted a pair of spacewalks together several years ago during Expedition 50, the first on January 13th, 2017, where they worked on the most recently completed set of battery replacements, where nickel-hydrogen batteries were replaced by lithium-ion batteries on the International Space Station. They also worked a couple of months later during Expedition 50, going outside together on March 24th, 2017, to lubricate the latching end effector at the end of the Canadarm2 and to prepare the Zenith port on the Harmony module of the International Space Station for the installation later on of the second of the 2 international docking adapters that are now used for commercial crew vehicles arriving at the International Space Station. So they are familiar with each other. They have their choreography pat, and they're ready to go outside once again to begin their 3rd spacewalk together, the 239th in the history of space station assembly, maintenance, and upgrades. The clock's up on the wall here in Mission Control, counting backward for a go for the depressurization of the Quest airlock. Before long, you see in this view Mark Vande Hei, NASA astronaut, on the right side of your screen. Megan McArthur's on the left. You'll see them attach jet-powered backpacks to the two spacewalkers' extravehicular mobility units. They're called SAFERs. That's the acronym for Simplified Aid for EVA Rescue. Those are the jet-powered backpacks that would be used in the highly unlikely event either of the crew members would become detached from the tethers that hold them in place as they go about their work on the outside of the Quest airlock. They then, one by one, will be moved into the outermost compartment of the two-compartment Quest airlock, called the crew lock, that you see Vande Hei at the threshold of. That then will be followed by the closing of that hatch. The two spacewalkers will hook themselves up to umbilicals inside the crew lock and await the green light while the depressurization of the crew lock section brings it down to vacuum as the precursor to their placing their suits on battery power to mark the official start of today's spacewalk. Today's spacewalk is the first of two in the next 4 days by Pesquet and Kimbrough. They'll go outside once again on Sunday, on Father's Day, to install the second of the two iROSA solar arrays that arrived on the SpaceX Cargo Dragon vehicle about a week and a half ago. This first of the two iROSA arrays will be installed to service the so-called 2B channel of the P6 truss of the International Space Station. The work that they will conduct on Sunday will be the installation of the 4B power channel arrays. And you can see in this graphic how the ISS Roll-Out Solar Array, these new arrays, look like when they're deployed adjacent to the legacy arrays, which are about twice as long as the new arrays. And again, these are not designed to replace the older arrays, but rather to augment the power generation for the International Space Station. Today's work will concentrate on the array to be installed on the 2B channel for the International Space Station. It's intricate work that involves a lot of loosening of bolts and a lot of work with power tools, high-tech space power tools that the crew will have at their disposal. We have about a 7-minute animation narrated by the lead spacewalk officer for today's EVA, Keith Johnson, in which he describes in detail what Pesquet and Kimbrough will be doing once they move outside of the Quest airlock.
At the start of the EVA, EV1, Thomas Pesquet, comes out first, followed by EV2, Shane Kimbrough. Thomas translates up to the front face of the truss and translates outboard. Thomas is setting up what we refer to as safety tether anchors. At this point, he'll drop the anchor point for both he and Shane. Shane will be retrieving an articulating portable foot restraint and putting his stowage bag onto it for translation outboard. Thomas makes his way out to the carrier that has the solar arrays stowed on it. Shane follows along the truss and meets Thomas at the carrier. The crew drops off pistol grip tools and bags in preparation for releasing iROSA from the carrier. Shane makes his way outboard onto the P6 truss element and stows the articulating portable foot restraint that he'll be using later on in the EVA. Continues translating outboard to the very end of the truss and stows his stowage bag. Thomas prepares the iROSA by releasing the first hinge bolt and stowing his pistol grip tool. Thomas makes his way outboard and releases an anti-rotation device, which keeps the primary bolt locked in place during launch loads. Thomas retrieves a handling aid for iROSA. We refer to this as a scoop. Meanwhile, Shane retrieves a crew lock bag and installs it on the lower support truss of the mod kit. He retrieves another scoop, another handling aid, and installs it on the mounting bracket of the mod kit. Shane retrieves one of the two sets of cables and pre-positions them for future installation. Shane retrieves his pistol grip tool and makes his way back inboard to join Thomas. Thomas prepares the release bolts down to the last few turns. Thomas installs one of the handling aids and makes his way back around iROSA. He changes out his pistol grip tool and makes his way down to the crew and equipment translation aid, or CETA cart, and retrieves the foot restraint that he'll use on the end of the arm for his work with iROSA. He installs the foot restraint at the end of the arm, puts it in the right position, and ingresses the arm. The arm then flies him into position to drive two bolts that are on the boom deployment system. Once these bolts have been released, the booms can be moved outboard, and this will help with the release of the solar array when it's eventually deployed. Thomas drives two of the outboard launch restraint bolts that hold the tube in place, and the arm maneuvers him for release of iROSA from the carrier. Meanwhile, Shane makes his way over to the carrier and gets into position for release. Shane drives the last few turns on the release bolts, and now the iROSA solar array has been released from the flight support equipment. He installs a handling aid, and Thomas is able to slide iROSA off of the carrier and remove it. Meanwhile, Shane is keeping an eye on the whole system to make sure that iROSA does not come into contact with the RMS grapple fixture, and away Thomas goes with iROSA. Meanwhile, Shane gets off of the carrier and translates outboard. He'll stow Thomas' safety tether hook in preparation for when Thomas comes off of the arm, and he'll continue his path outboard. He stows his pistol grip tool, makes his way to his foot restraint, and ingresses. While he's getting into his foot restraint, Thomas is continuing his path, holding on to iROSA while the arm flies him as far outboard as it can reach. He hands off the iROSA to Shane. They swap tethers. Shane has control of iROSA and is left holding it, while Thomas goes back to his egress position. He gets out of the arm, changes his safety tether, and makes his way back to where Shane is holding iROSA. He then rotates Shane into position so that iROSA is handed off to the next point. Thomas ingresses his foot restraint and receives iROSA. Shane egresses his foot restraint, moves outboard, and gets into position to help Thomas install iROSA onto its final location on the mod kit. One of the two handling aids is removed before installing onto this mounting bracket. The two crew members work together to align it and put it into a soft capture feature. Once it's installed, the other handling aid is removed, the final hinge restraint bolt is loosened, and iROSA is now able to rotate into its fully deployed, fully extended position. The two crew members work together to swing it into the single tube. Once it is in position, Shane stows the two handling aids. Thomas gets into position to drive the hinge bolts. These two bolts hold the two halves of the iROSA solar array into a single tube. These bolts are delicate pins, so the final torque to get them into position is done with a hand tool so that we don't over-torque those bolts. Once that's in place, there are 8 mounting bolts that hold all of the iROSA solar array onto the mounting bracket. Thomas will drive the first 4, followed by Shane driving the second set of 4. Shane and Thomas will work together to install the electrical cables that hook up to iROSA. One set goes to the right side and the other set goes to the left side, and they are finally hooked up in place on the legacy solar arrays. That's done during eclipse. After those cables are installed, the crew gets into position to drive the final 2 bolts that are holding iROSA in the pre-deployed position. Once these 2 bolts have been driven, iROSA is free to extend itself into its deployed position. After the crew's verified that the solar array is in the right position and it's fully deployed, they drive 2 tensioning bolts. This allows the sail to be tensioned into its final configuration. Once iROSA has been fully deployed, there are some checkout steps that are performed to make sure that everything is hooked up correctly, and the crew cleans up the worksite. They retrieve the handling aids and the pistol grip tools, and they prepare for the second EVA in the series. To do this, they take their foot restraints and move them to the other side of the P6 truss structure. This will be the work site for the second EVA. Each crew member has their own foot restraint, and they'll move them to the other side. The crew repositions the stowage bag that's holding the other set of cables to the other side of the truss, pre-positions it for the next EVA. The crew will do an inventory of all their tools and their hardware, and they'll start their path back to the airlock. On their way back, they'll stop at the carrier, pick up the last crew lock bag and the last pistol grip tool, and make their way inboard. When both crew members are back at the airlock, they'll retrieve a foot restraint that has been causing us problems and bring it inside the airlock to inspect. Shane will enter the airlock, followed by Thomas, and that ends the first EVA.
And the electrical systems officer here in Mission Control has indicated that if all goes as planned, we should get some indication that the newly deployed ISS Roll-Out Solar Array is generating the proper amount of power either before or during the time frame that the crew is re-entering the Quest airlock near the end of today's spacewalk. Once again, as you saw in the animation, iROSA, you'll be hearing that acronym frequently throughout the course of our coverage today. iROSA standing for ISS Roll-Out Solar Array. It will be positioned in front of the legacy solar arrays, or the older solar arrays on the P6 truss of the station. It attaches to the existing beta gimbal assembly that permits it the use of existing sun tracking, power distribution, and the power distribution to the proper channel. In this case, the first array to be installed and deployed today will service the so-called 2B power channel, the first of 6 power channels to be augmented during the course of these iROSA installation and deployment activities. These arrays will shadow approximately 2/3 of the legacy arrays. They're connected to the same power system to augment the existing supply. The 2 arrays to be deployed, the first today and the second on Sunday, will be electrically combined and both provide power to the ISS, resulting in the increased power performance compared to the original legacy ISS solar array. And as we mentioned earlier, each of these new arrays will produce more than 20 kilowatts of power, and when all 6 are finally deployed and activated, they will total about 120 kilowatts of augmented power for the International Space Station. In the equipment lock section of the Quest airlock, Mark Vandehei on the right side of your screen and Megan MacArthur on the left are making final checks to the suits of Shane Kimbrough that you see in the middle of your view. You're looking over the shoulder of Thomas Pesquet. Pesquet, who will be wearing the suit bearing the red stripes today, is extravehicular crew member number 1, or EV1. And again, he'll be wearing the helmet camera bearing the number 20 in the lower right-hand side of your screen once they are turned on following the crew's exit from the crew lock section of the Quest airlock. Shane Kimbrough is designated today as EV2. He is wearing the unmarked suit and will have a helmet camera bearing the number 22 during the course of today's spacewalk. And as mentioned earlier, both spacewalkers will also be equipped with high-definition helmet cameras to provide even better views of some of the intricate work that they're going to be conducting to loosen up bolts and the installation of these new solar arrays on what are called mod kits, or modification kits, that were installed on previous spacewalks. The crew began their suit-up activities about 1 a.m. Central Time this morning. They, again, were assisted in being suited up by Mark Vandehei NASA astronaut that you see on the right side of your screen in the blue shirt. They then began to pre-breathe pure oxygen to cleanse their systems of nitrogen in the customary procedure that prevents any possibility of decompression sickness from setting in once they move out into the vacuum of space. A good view down the length of the equipment lock section of the Quest airlock, as you see Megan MacArthur checking out suit systems along with Van de Heye. She will be operating the Canadarm2 robotic arm from the workstation in the Destiny laboratory during the course of today's spacewalk. The money shot for today is likely to be the movement of Thomas Pesquet in a foot restraint at the end of the Canadarm2, like a telephone repairman at the end of a cherry picker, who will be hauling this first iROSA solar array to the work site.
Purge in step 20. The BEDOX canisters are temp stowed node 1 deck 3, serial numbers 1033 and 1034.
We copy. You're go to proceed, and those are good numbers.
And we have resumed to the pre-breathe clock.
Again, MacArthur will be the robotic arm operator during the course of today's spacewalk as she moves Thomas Pesquet to the worksite. But Pesquet will be carrying that iROSA solar array, which on Earth weighs 750 pounds. Of course, in weightlessness, it doesn't weigh anything other than the mass that he'll be hauling to a handoff to Shane Kimbrough, who will then hand it back to Pesquet, and the two spacewalkers will work in tandem to position that array for its installation on the modification kit, which is at the mast canister at the base of the P6 solar array. We're about 37 minutes away from beginning the depressurization of the crew lock section of the Quest airlock. Over the course of the next half hour, the simplified aid for EVA rescue backpacks will be affixed to the back of the spacesuits for Pesquet and Kimbrough, and they'll be moved into the Quest airlock. The hatch will then be closed, and they'll be isolated from the rest of the crew members on the International Outpost for the remainder of the day. At this hour, the International Space Station is flying 258 statute miles over the Ukraine, south of Kiev, moving from northwest to southeast in an orbit inclined 51.6 degrees to either side of the equator. Some of the timing of today's spacewalk is measured to be conducted during orbital nighttime, particularly the actual hookup of power connectors for the new solar arrays, so they're not hot, quote unquote, at the time that they're acquiring electrical power from the sun during an orbital daylight pass. So there will be times in which the crew, if they're running slightly ahead in the timeline, will be asked to simply stop so that the timing of certain tasks to be conducted deliberately during an orbital nighttime times out correctly to meet the particular technical requirements for the installation and deployment of the ISS Roll-Out Solar Arrays. Inside the equipment lock section of the Quest airlock, Megan MacArthur and Mark Vandehei are beginning work to affix the first of the simplified aid for EVA rescue or safer backpacks to Thomas Pesquet's spacesuit. Shane Kimbrough will be next up to have his safer unit installed. Again, those jet-powered backpacks are designed to provide the capability, if necessary, in the unlikely possibility that a crew member would become detached or untethered during the course of the spacewalk, they could propel themselves back to the structure of the International Space Station and into safety. This is Mission Control Houston. In the field of view, in the foreground is Space Station Commander Aki Hoshide from the Japan Aerospace Exploration Agency, as Megan MacArthur and Mark Vande Hei are finalizing the attachment of the jet-powered backpack called the Safer to Thomas Pesquet's spacesuit. Again, you see the red stripes on his legs. That's indicative of his designation as extravehicular crew member number 1, or EV1. He'll be first out of the crew lock section of the Quest airlock once the hatch is open and the suits are placed on internal battery power to begin the official start of today's excursion by him and Shane Kimbrough, the NASA flight engineer, who will spend 6.5 to 7 hours out in the void of space today, attaching the first of a half dozen ISS Roll-Out Solar Arrays to augment the power capability of the International Space Station. Thomas Pesquet is now inside the crew lock section of the Quest airlock. Shane Kimbrough now will be assisted in the donning of his Safer jet-powered backpack before being moved across the threshold into the crew lock section to join Pesquet. In the equipment lock section of the Quest airlock, a wealth of spacewalking experience abounds. Mark Vande Hei with 4 spacewalks to his credit in his career. Aki Hoshide, with his back to the camera, has conducted 3 spacewalks before. Megan MacArthur's previous flight into space, of course, was part of the crew for the final servicing mission of the Hubble Space Telescope. She operated the shuttle's robotic arm to capture and later deploy the Hubble. She will be operating the Canadarm2, the space station's robotic arm, today to transport Thomas Pesquet around with the ISS Roll-Out Solar Array to the work site at the far port section of the International Space Station, where he and Shane Kimbrough will work in tandem to install that solar array to a so-called mod kit that was hooked up on a previous spacewalk, and then, of course, to loosen bolts and other mechanisms to permit the deployment of that array. This is Mission Control Houston. You are looking live inside the equipment lock section of the Quest airlock of the International Space Station. You're looking at NASA flight engineer Shane Kimbrough and his extravehicular mobility unit. His crewmate, Megan MacArthur and Mark Vandehei, are across the threshold that separates the equipment lock from the crew lock section of Quest. Thomas Pesquet of the European Space Agency is already inside the crew lock. Shane Kimbrough soon to be moved inside to join his spacewalking colleague for today, as we are about 15 minutes away from the start of the depressurization of the crew lock section of Quest. That will be the precursor for the start of today's spacewalk by Pesquet and Kimbrough to install the first of a half dozen new solar arrays to augment the power system of the International Space Station. Today's work to be conducted on the far left or port truss of the station at the P6 truss, the first truss element of the station to carry a solar array that was launched aboard the Space Shuttle Endeavour in December 2000 on the STS-97 mission. This is Mission Control Houston. Both Thomas Pesquet and Shane Kimbrough now inside the crew lock section of the Quest airlock. Aki Hoshide in the foreground, assisted by Mark Vandehei, now beginning to close the hatch. That will isolate the two spacewalkers for today. We're about 7 minutes away for a go for the depressurization of the crew lock section that will be done in a two-step fashion. While we have a moment, let's replay for you the 7-minute animation narrated by the lead spacewalk officer, Keith Johnson, who will outline all of the tasks that face Pesquet and Kimbrough in today's spacewalk.
At the start of the EVA, EV1, Thomas Pesquet, comes out first, followed by EV2, Shane Kimbrough. Thomas translates up to the front face of the truss and translates outboard. Thomas is setting up what we refer to as safety tether anchors. At this point, he'll drop the anchor point for both he and Shane. Shane will be retrieving an articulating portable foot restraint and putting his stowage bag onto it for translation outboard. Thomas makes his way out to the carrier that has the solar arrays stowed on it. Shane follows along the truss and meets Thomas at the carrier. The crew drops off pistol grip tools and bags in preparation for releasing iROSA from the carrier. Shane makes his way outboard onto the P6 truss element and stows the articulating portable foot restraint that he'll be using later on in the EVA. Continues translating outboard to the very end of the truss and stows his stowage bag. Thomas prepares the iROSA by releasing the first hinge bolt and stowing his pistol grip tool. Thomas makes his way outboard and releases an anti-rotation device, which keeps the primary bolt locked in place during launch loads. Thomas retrieves a handling aid for iROSA. We refer to this as a scoop. Meanwhile, Shane retrieves a crew lock bag and installs it on the lower support truss of the mod kit. He retrieves another scoop, another handling aid, and installs it on the mounting bracket of the mod kit. Shane retrieves one of the two sets of cables and pre-positions them for future installation. Shane retrieves his pistol grip tool and makes his way back inboard to join Thomas. Thomas prepares the release bolts down to the last few turns. Thomas installs one of the handling aids and makes his way back around iROSA. He changes out his pistol grip tool and makes his way down to the crew and equipment translation aid, or CETA cart, and retrieves the foot restraint that he'll use on the end of the arm for his work with iROSA. He installs the foot restraint at the end of the arm, puts it in the right position, and ingresses the arm. The arm then flies him into position to drive two bolts that are on the boom deployment system. Once these bolts have been released, the booms can be moved outboard, and this will help with the release of the solar array when it's eventually deployed. Thomas drives two of the outboard launch restraint bolts that hold the tube in place, and the arm maneuvers him for release of iROSA from the carrier. Meanwhile, Shane makes his way over to the carrier and gets into position for release. Shane drives the last few turns on the release bolts, and now the iROSA solar array has been released from the flight support equipment. He installs a handling aid, and Thomas is able to slide iROSA off of the carrier and remove it. Meanwhile, Shane is keeping an eye on the whole system to make sure that iROSA does not come into contact with the RMS grapple fixture, and away Thomas goes with iROSA. Meanwhile, Shane gets off of the carrier and translates outboard. He'll stow Thomas' safety tether hook in preparation for when Thomas comes off of the arm, and he'll continue his path outboard. He stows his pistol grip tool, makes his way to his foot restraint, and ingresses. While he's getting into his foot restraint, Thomas is continuing his path, holding on to iROSA while the arm flies him as far outboard as it can reach. He hands off the iROSA to Shane. They swap tethers. Shane has control of iROSA and is left holding it, while Thomas goes back to his egress position. He gets out of the arm, changes his safety tether, and makes his way back to where Shane is holding iROSA. He then rotates Shane into position so that iROSA is handed off to the next point. Thomas ingresses his foot restraint and receives iROSA. Shane egresses his foot restraint, moves outboard, and gets into position to help Thomas install iROSA onto its final location on the mod kit. One of the two handling aids is removed before installing onto this mounting bracket. The two crew members work together to align it and put it into a soft capture feature. Once it's installed, the other handling aid is removed, the final hinge restraint bolt is loosened, and iROSA is now able to rotate into its fully deployed, fully extended position. The two crew members work together to swing it into the single tube. Once it is in position, Shane stows the two handling aids. Thomas gets into position to drive the hinge bolts. These two bolts hold the two halves of the iROSA solar array into a single tube. These bolts are delicate pins, so the final torque to get them into position is done with a hand tool so that we don't over-torque those bolts. Once that's in place, there are 8 mounting bolts that hold all of the iROSA solar array onto the mounting bracket. Thomas will drive the first 4, followed by Shane driving the second set of 4. Shane and Thomas will work together to install the electrical cables that hook up to iROSA. One set goes to the right side and the other set goes to the left side, and they are finally hooked up in place on the legacy solar arrays. That's done during eclipse. After those cables are installed, the crew gets into position to drive the final 2 bolts that are holding iROSA in the pre-deployed position. Once these 2 bolts have been driven, iROSA is free to extend itself into its deployed position. After the crew's verified that the solar array is in the right position and it's fully deployed, they drive 2 tensioning bolts. This allows the sail to be tensioned into its final configuration. Once iROSA has been fully deployed, there are some checkout steps that are performed to make sure that everything is hooked up correctly, and the crew cleans up the worksite. They retrieve the handling aids and the pistol grip tools, and they prepare for the second EVA in the series. To do this, they take their foot restraints and move them to the other side of the P6 truss structure. This will be the worksite for the second EVA. Each crew member has their own foot restraint, and they'll move them to the other side. The crew repositions the stowage bag that's holding the other set of cables to the other side of the truss, pre-positions it for the next EVA. The crew will do an inventory of all their tools and their hardware, and they'll start their path back to the airlock. On their way back, they'll stop at the carrier, pick up the last crew lock bag and the last pistol grip tool, and make their way inboard. When both crew members are back at the airlock, they'll retrieve a foot restraint that has been causing us problems and bring it inside the airlock to inspect. Shane will enter the airlock, followed by Thomas, and that ends the first EVA.
And so both of you monitor your seat pressure gauge is less than 5.5, and if it ever gets above 5.5, stop the depress.
Copy, EV1. Depress pump man ISO is open.
Copy, open, and let us know when the crew lock at 6.0, expect an alert tone. You don't have to let us know, but expect an alert tone. Do let us know when you get to 5.0.
This is Mission Control Houston here in the Space Station Flight Control Room. Ron Spencer standing up. He is the flight director for today's spacewalk by Pesquet and Kimbrough. He is joined on console to his right by Canadian Space Agency astronaut Jenny Sidey, who is the ground IV, basically the spacewalk communicator, who will be running through all the procedures step by step with Pesquet and Kimbrough once they move outside of the Quest airlock. And to her right is veteran astronaut Drew Feustel. He has a very impressive spacewalking record in his career, 9 spacewalks for a total of 61 hours and 48 minutes of spacewalking time. He will basically run the procedures through the point at which the crew will place their suits on internal battery power to begin the official start of today's spacewalk, and then he'll hand over the communications chores to Jenny Sidey for the remainder of the spacewalk. Feustel will be available to talk to the other crew members inside the International Space Station during the course of today's activities. The depressurization of the crew lock section of Quest is underway. This will be conducted in a 2-step fashion. First, to bring the crew lock section down to 5 pounds per square inch of pressure. There will be leak checks, communications checks with the crew before the depressurization continues to bring the crew lock down to vacuum.
P4.8. Modulating.
To recap, this will be the 239th spacewalk in International Space Station history in support of assembly maintenance and upgrades. The 7th spacewalk for Shane Kimbrough, who will be wearing a helmet camera with the number 22 in the lower right-hand corner of your screen once it is turned on following the crew's exit from the crew lock section of Quest. This will be the 3rd spacewalk in Thomas Pesquet's career. He will be wearing helmet camera number 20, and both crew members outside will be also equipped with high-definition helmet cameras for even better enhanced views of the work that they'll be doing outside. Pesquet, as extravehicular crew member number 1, will wear the suit bearing the red stripes. Shane Kimbrough's suit as extravehicular crew member number 2 is unmarked.
10 PSI. And PSI. It's under 5 on my suit. Yeah, same here. PSI on the DCM. LOC.
Again, you guys are all over it, but when the crew lock is at 6.0, expect an alert tone.
Copy. Copy.
Mark Vande Hei in the equipment lock section of Quest, monitoring the depressurization of the crew lock section, the outermost section of the 2-compartment Quest airlock. It will be taken down to about 6 pounds of pressure per square inch, almost 5, before we pause to conduct leak checks on the crew members' suits, final communications checks before the green light is given for Pesquet and Kimbrough to open up the hatch on the crew lock section. The outer thermal cover will be opened as well, and the crew members then will be given the green light to place their suits on internal battery power, which will mark the official start of today's spacewalk.
One, approaching 6.0. Copy.
Once the two spacewalkers have placed their suits on internal battery power, Pesquet will be first out of the Quest airlock. He will be joined just a few moments after that by Kimbrough, and the two will begin to check out all of their equipment, make sure their tools and tethers are properly configured before they make their way over to the work site on the far left side of the truss of the International Space Station at the P6 truss of the complex.
iPhone 1. Okay. Five. Okay.
Copy 5.0, Shane, deep press pump manual isolation valve to close.
Close.
And expected alert tone.
Alert for now.
Shane, did you get the deep press pump manual isolation valve to close?
Yep, it's closed.
And I didn't copy.
Yes, closed.
Closed. Okay, for both of you, on your GCM, switch the display to status until leak check question mark is displayed, and then display to yes, hold for a few seconds, and follow the displayed instructions.
Copy. Copy. Air check question mark. Check complete. And for here, go to 3VA. Okay. Mark.
Copy. Both of your leak checks are complete, and you're in the process of moving your O2 actuators to EVA.
EVA for EV1. Looks like I'm in EVA, but it's not showing it. My DCM. Good lock.
So Shane, depress pump manual isolation valve to open and expect an alert tone.
Okay, it's open.
Copy, open. The emergency MPEV is now open. Monitor your suit pressure gauge stays less than 5.5.
Copy. Copy.
Mark Vande Hei continuing to monitor the procedures as we have now resumed the depressurization of the crew lock down to vacuum, which will be the precursor to the crew opening the outer hatch to the crew lock and placing their suits on internal battery power to begin today's spacewalk.
.0.
Once the hatch is open and the spacewalk begins, Megan McArthur will make her way to the robotics workstation inside the International Space Station. She'll be at the controls of the Canadarm2 robotic arm to drive Thomas Pesquet from one area to the work site on the P6 truss, the far left side of the truss backbone of the International Space Station. He will be carrying that first iROSA array, the ISS Roll-Out Solar Array, once it is removed from a flight support structure to which it is attached. The second of these two solar arrays, the first pair of solar arrays, will be the subject of Sunday's spacewalk, again by Pesquet and Kimbrough, as they work to hook that one up to the 4B channel of the P6 truss. The today's array work will service the 2B channel of the P6 truss. These are the first pair of 6 such iROSA solar arrays that will augment power for 6 of the 8 power channels on the International Space Station.
Copy 2.0, Shane, depress pump manual isolation valve to close.
Yeah, main ISO valve is closed.
Shane, on the UIA, switch the depress pump power to off.
Depress pump power off.
Report the initial configuration for egress of your tethers.
Okay, I can do that. Let's see on Shane's configuration on his right gearing extender, it takes tether, close and lock, goes to the waist tether, close and lock, goes to the airlock, waist tether, close and lock on both sides. On his left gearing extender, he's got his red hook, closed and locked, goes to the red reel, which is unlocked, yellow hook, closed and locked to his green reel, unlocked, his green reel goes to, his green hook goes to his red reel. Anchor hook.
European Space Agency astronaut Thomas Pesquet across that hatchway that you see Mark Vande Hei on this side of the hatch as Pesquet and Kimbrough report the configuration of their tethers prior to the point at which the crew lock section of Quest reaches vacuum, which should be just a few moments from now.
He's on my red reel. Green reel, yeah, it's closed but not locked. And my anchor hook is on my main workstation.
All right, Thomas, could you confirm that your right and left waist, actually you have a hard time checking your short waist tether. Check that your waist tether on the same side as your safety tether pack. The waist tether small hook is closed and locked on the gearing extender.
That is correct, Mark. The left side where my safety tether pack is, and my waist tether closed and locked. And on the other side is on my gearing, closed and locked.
Could you confirm that the airlock waist tether, the one that's directly attached to the airlock gearing extender, has both of its hooks, the large and small hooks, closed and locked?
That is correct. Small hook closed and locked, and large hook closed and locked on Shane's large hook, closed and locked.
Hey, Houston, do you have anything you want to double check with them?
That is a good tether config. Thank you all.
All right, thanks. Good work, gentlemen. On both your DCMs, when the crew lock DPDT is about 0, expect an alert tone. And then tomorrow, when the EV hatch delta pressure is less than 0.5 psi, you are go to open and stow the EV hatch.
Copy, Mark. Do I take the MPEV open? Is that correct?
The emergency MPEV is open right now.
It is open, okay.
There's nothing on there about opening the EV hatches.
Okay.
MPEV.
Okay, drops really slowly. Yeah.
Not open it, keep it closed. Let me say that one more time. When you get to less than 0.5 psi on the hatch, you'll open and stow the hatch, but keep the MPEV on that hatch closed.
Copy. When I get to less than 0.5 psid in the hatch, I open the hatch and MPEV closed.
The airlock, Houston, we have about 8 to 10 minutes until we're at a time where the delta P is going to be less than 0.5. So we'll be following along with you, and I'll give you direction on that hatch when we're ready.
Okay, Jenny. Thanks.
Good morning, Jenny.
And hey, while we are waiting on this, big thank you to Mark and Megan and Aki for, I think, doing a fantastic job in getting us ready to go out the door. That was really nicely executed. And I'll extend this to all the prep shift. I don't know if those guys are still on console. If they are, congrats on the job well done. If they're not, please pass the word.
Hey, Thomas, thanks. It was certainly an honor for all of us to be able to participate in this event you're working on today to help improve the space station. We are all looking forward to continued success as you do your hard work today.
Mark.
With those words, Mark Van de Heij will turn the communications duties over to Jenny Sidey, the Canadian Space Agency astronaut here in Mission Control, who is the ground IV or intravehicular crew member, essentially the spacewalk communicator for today's excursion outside by Pesquet and NASA astronaut Shane Kimbrough.
Thomas, just to put on the belt and suspenders to make sure we got everything possibly covered. What is the current status of the MPEV on the EV hatch?
It is closed, Mark, closed.
Okay, thanks.
Thanks for checking.
Ground copies, that's a good config.
We're in a brief handover between satellites on the tracking and data relay satellite system. We will regain our downlink television capability and communications with the crew momentarily. Everything has proceeded by the book throughout the overnight hours, setting the stage for the start of today's spacewalk, the 7th out of the International Space Station this calendar year.
Turn my lights on, come up.
What?
Here we go, turn my lights on and leave them.
This view from an external camera on the International Space Station focused on the Quest airlock of the complex. Inside the crew lock, Pesquet and Kimbrough soon to place their suits on battery power to begin the start of today's spacewalk. The International Space Station flying from southwest to northeast across the southeastern Pacific Ocean, soon to cross over Central America in an orbit inclined 51.6 degrees to either side of the equator.
This is point 8, GSID on the hatch, manual gauge.
Copy, Thomas.
I have a reminder for Thomas. We're not at the point yet where we want you to actuate the hatch, but after you fully rotate the hatch handle, when we are at that point, we'll have you pause for 1 second before opening the hatch.
Copy, Jenny.
Hey, Jenny, it's Mark. Does Thomas go to start that process when he sees 0.5 psi delta P on the EV hatch? Or does he have to wait till you call him?
Checking.
I'll check with you, Jenny, in any case.
We're thinking that that hatch is going to lag, as you guys might be expecting. So if we see it first, we'll let you know. But if you see it, you can open the hatch. Just a reminder, after you fully rotate that handle, we're looking for a 1 second pause before opening.
Copy, Jenny. Second pause after rotating the handle. ISS point 6.
Copy, Thomas.
Flying into an orbital sunrise, the International Space Station's Quest airlock now clearly in view. Soon the outer thermal hatch will pop open, and the inner hatch for the crew lock section of Quest will be opened. We're just about down to vacuum, and you'll start to hear the calls for final communications and systems checks for the two spacewalkers for today, Thomas Pesquet of the European Space Agency and Shane Kimbrough from NASA. As mentioned earlier in the broadcast, these two astronauts conducted two spacewalks together during Expedition 50 in January and March of 2017. The first was work that was ongoing as part of the sequence of events that swapped out batteries for the power system on the International Space Station. The second of their two spacewalks together 4 years ago saw them lubricate and service the latching end effector on the Canadarm2 robotic arm and prepare the zenith or space-facing port on the Harmony module for the installation later on of the second of the two international docking adapters.
And Thomas, in the airlock, I'm showing the telemetry showing 5 psi.
Copy.
Correction.
0.5.
Less than 0.5 psi.
Copy, Mark.
Once you've opened the hatch, I'll go ahead and put the emergency MPEV to closed. And then Jenny, it'll be completely over to you.
Copy, and we concur. We see that pressure less than 0.5 psi.
And that's what I have on the manual gauge as well, Jenny. So if you concur, I'm going to go ahead and rotate that handle and pause for a second.
Affirm.
All right, unlock. Rotating clockwise to unlatch. Hard stop. I'm going to pause. And then pull the handle up. Nicely done.
And the hatch to the crew lock section of Quest now open at 7:09. We're standing by now for final systems checks and the suits being put on internal battery power to mark the official start of today's spacewalk.
I'm going to move it. Yeah, can you move a little bit to the, there you go, forward and
If I get to it.
No, you just move you, because I think I'm contacting you. Okay. If you go as much forward as you can, Shane.
I'm full, all forward.
There you go. Okay, hatch is open.
Nice.
Secured for daylight.
Nicely done, Thomas. The emergency MPV is now closed. All right, Jenny. Good luck today, and look forward to talking to you at the end.
All right, ground copies. Thank you, Mark. Well done. I am ready to pick up with you guys on your DCMs. Switch power to BAT. Stagger your switch throws and expect a warning tone. Check display switch functional.
Copy. Power to BAT. Weathering BAT.
Power to BAT, EV2.
Restart.
Copy, power to BATs. Looking for a good display on Shane as well.
Good display. Good reset.
On the UIA, switch power for EV1 and EV2 to off, OFF, and check for LEDs off, OFF.
Okay, powers EV1 and 2 are off, LEDs are off.
Switch 2 off, expected.
Disconnect SCUs from your DCMs and install your DCM cover.
Dark. View disconnected, cover in place.
And for EV2.
Copy both. Stow your SCUs in their pouches.
Yes. You want us to use in the pouch.
Copy.
This is Mission Control Houston. Thomas Pesquet of the European Space Agency and NASA's Shane Kimbrough have placed their suits on internal battery power at 7:11 a.m. Central Time, 8:11 a.m. Eastern Time, marking the official start of today's spacewalk, the 239th in support of space station assembly maintenance and upgrades. Again, start time for today's spacewalk officially measured at 7:11 a.m. Central, 8:11 a.m. Eastern Time.
Backside EV1.
Backside EV2.
Switch water on, O-N.
Water on, EV1.
Water on, EV2.
Check DCM blank, bite off.
DCM blank and bite off, EV1.
DCM blank, bite off, EV2.
Copy all. Temperature control valve set as desired.
The voice you're hearing here in Mission Control talking to the two spacewalkers is that of Canadian Space Agency astronaut Jenny Sidey. She is the ground IV, or the spacewalk choreographer, who will be working step by step through all of the procedures for today's spacewalk. The hatch is open to the Quest Airlock's crew lock section. You'll be seeing Thomas Pesquet wearing the suit bearing the red stripes as extravehicular crew member number 1. He'll be emerging just a few moments from now once he and Kimbrough have completed an inventory of all the tools they'll be taking outside with them.
All right, copy. And with that, we are ready, Thomas, for you to open the hatch thermal cover.
Copy, opening the hatch thermal cover. CAT. Goes to the gearing.
And Thomas, you'll be stowing the hook on the stiffener tether point and cinching the snap strap until snug.
Copy. The hook is on the tether point and the strap is cinched. I see 6 black lines.
Copy. We are expecting.
And the thermal cover is open.
Copy.
The outer thermal cover on the Quest airlock opens just as the International Space Station flies 258 statute miles over Miami.
I go to egress. Ready?
Affirm, Thomas, you can egress the airlock with crew lock bag number 1. We'll have you verify the forward hatch pit pin is engaged.
Copy, I'm egressing the airlock. Forward hatch pit pin engaged. I put down a local feather. And my crew lock bag.
Copy. You can get that crew lock bag on your VRT, and when you're ready, give Shane a go for egress.
Copy.
Come back in.
A little bit.
Good.
When you're right on that lower bag.
Yeah.
Okay, I got BRT right on it. BRT on the crew lock bag. Bring back out. And then I have the red on it, I have my BRT. You can release.
And our first view of Thomas Pesquet, extravehicular crew member number 1 today, wearing the suit with the red stripes, representing the European Space Agency today as he begins the 3rd spacewalk of his career.
Yeah, I got it. Got it. Nice.
I have a ret on the IDA bag, cable bag, released from airlock tether.
Copy.
Copy, Shane.
You know when you're ready, Thomas?
I'm ready. You can come out.
Okay. Good and caught him.
Yeah, good. Go straight, you'll be good. Yeah, nice.
On the lights.
Go ahead and close the thermal cover when you...
Yeah, I gotta come back.
You gotta come back.
That's right. The bats are on my lights.
Yeah.
Copy. Now that you're both egress, you can turn on your HECAs, and we're ready to copy
Rotate your right shoulder.
buddy checks when you are.
Stand by, Jenny. Rotate your right shoulder, Shane.
What's that?
To your right shoulder. Rotate. There you go.
Got it. Thanks.
Okay, Jenny, can you say that again?
Okay, I copy. You can turn on your HECAs when you're ready, and then I'll copy buddy checks when you're ready.
Okay. Guys on EV1.
EV2. I'm gonna get this thing untangled here. Come on.
What?
Get the red untangled around my checklist.
Oh. Let's see. You have to go underneath. You have to bring it back to me.
It's around my safety tether too.
Yeah. Okay. And release from your left arm.
Once Kimbrough is outside to join Pesquet, we should be seeing our first view from helmet cameras. Each crew member has two types of helmet cameras, the conventional ones that you are accustomed to seeing, with Pesquet's number on his helmet camera of 20 in the lower right-hand corner once they're activated. Kimbrough's helmet camera number will be 22. They also will be turning on high-definition cameras that are mounted on their spacesuits for even better views of some of the work that they'll be doing once they reach the P6 truss on the far left section of the backbone of the International Space Station. Shane Kimbrough now on the right in the unmarked suit. Extravehicular crew member number 2 has joined Pesquet outside. They will make sure that they have all of their tools and tethers configured properly before they begin to make their way out to the P6 truss.
Okay. I think now we're good.
Sweet. Yeah, nice work.
Okay. So, you ready for buddy checks?
Ready?
On you, I see 2 green LEDs. Then going down, I see 3 tabs up and a little bit to your left shoulder. 3 tabs up for BRT. 2 handles down, and I see the waist tether is going from your right steering extender locked black on black to the airlock waist tether locked black on black, both the big hook and the small hook. Looks like a good toothpick. Okay. And you got the IDA bag on your mini workstation right there. Yeah, that's what it is.
All right, I see 2 green lights on you. Lights are on, visor down. Mini workstation tabs, 1 and 2 are up. BRT tab is up. Safer handles are down. And I see your safety tethers just out your left side there. It all looks clear. Your product bag looks good behind you. Like you're in a good config.
Okay, sounds good. With that, Jenny, if you agree, I'll make my way to P1.
Copy. Good buddy checks. I'll just take a baseline HAP check from you, and then we can get to translating, Thomas.
Correct. And the HAP is dry for EV1.
Dry HAP, BD2.
Copy dry HAP. With that, Thomas, you're right. You can translate to P1. We're looking for Bay 12. I'll have a mile marker for you when you're ready. And Shane, you'll be attaching the cable bag bundle to the APFR and the airlock with 12.
Copy.
Shane Kimbrough reporting good configuration of all the tools and tethers, the HAP reference made by them and spacewalk communicator Jenny Seide here in Mission Control is the acronym for Helmet Absorption Pad. That is the device in the spacewalkers' helmets to do exactly what it's implied, and that is absorb any perspiration or other condensation that may build up inside their helmets during the course of the spacewalk. The two spacewalkers placed their suits on internal battery power at 7:11 a.m. Central Time, 8:11 a.m. Eastern Time to mark the official start of this spacewalk. The 239th for station assembly maintenance and upgrades, the 7th for Shane Kimbrough, and the 3rd for Thomas Pesquet.
All right, I'm on phase 1. The fixed status is clear. To my report.
Copy, Thomas. You're looking for mile marker 9180.
9180, copy, Jenny. Thanks.
Good words, just under the FHRC. Shane, once you've bundled that cable bag to the APFR, you can stow the APFR in your BRT.
See that? All right, it's bundled on there.
Our first helmet camera view from Thomas Pesquet as he begins to make his way down the port truss of the International Space Station, incrementally using handrails to make his way towards the ultimate destination, which is the P6 truss, where he and Kimbrough will begin to work to remove the iROSA, the ISS Roll-Out Solar Array, from flight support equipment that's mounted on the truss of the station to begin the intricate process of unbolting a variety of mechanisms that will lead to the deployment of that array later in today's spacewalk.
Okay, my anchor hook on 652, closed and locked, black on black.
Copy. Good config for your anchor hooks. Looking for a check on your reels.
Copy, Jenny, and my green reel is unlocked. My red reel is unlocked.
Copy. Green and red reels unlocked. You can tether to EV2's anchor hook.
Copy. Okay, Jenny, I'm tethered to EV2's anchor hook. My left waist tether.
Copy, Thomas. You'll be attaching EV2's anchor hook to 3651, which is nadir of the handrail you placed your anchor hook on.
Copy, 3651. EV2 anchor hook.
Good words.
EV2 anchor hook is on 3651. The gate is closed, slide unlocked, black on black.
Copy. That is a good load path. With that, I see Shane has picked up the APFR at the airlock. So when you're ready, Thomas, you can give Shane the go to release his tether from the airlock waist tether.
Shane, you're tethered to 3651. A good anchor hook. You have the go. You pick up your waist tether and begin the translation.
Okay, copy that. Thanks, Thomas.
And I'm resuming my translation to the southern silicon.
Say your last. Could you repeat your last?
Did you copy my last? I'm resuming my translation to the starboard silicon.
Okay, copy, Thomas. You'll be translating to the FSE Stanton Delta. I have a warning and cautions for you when you're ready.
And Jenny, I'm at the MT. I am ready for the warning and caution.
Warning, grapple shaft and curvet coupling teeth are no touch zone. Caution, no sudden movements or quick stops on the FSE. We want you to be translating slowly. Wait until FSE motion dampens out before imparting any loads. When Shane is on the FSE as well, do not simultaneously impart loads and do not contact iROSA blankets.
Copy on, Jenny, thanks. And I'm at the starboard silicon.
Copy, Thomas.
I'll make my way up.
He closed in thermal cover. It doesn't seem to want to stay closed.
Copy, Shane. You're closing the thermal cover.
It's not staying closed, though, Jenny.
Copy. We're looking into that, Shane. In the meantime, can I get check on your reels? We want them unlocked. And Thomas, we see you on the FSE. You're looking to stow your crew lock bag on the tower handrail.
I'll be stowing a crew lock bag on the tower handrail on the FSE.
Shane Kimbrough completing the configuration of the outer thermal hatch cover at the Quest airlock, while his spacewalking crewmate, Thomas Pesquet of the European Space Agency, makes his way towards the flight support equipment, upon which the first pair of ISS Roll-Out Solar Arrays are mounted. The International Space Station flying just beyond Paris.
That could be in in the way. Can you get your eyes on anything that might be obstructing it?
Yeah, it's a waste tether, thanks.
Copy.
Okay, thermal cover is closed. Thank you.
Copy, Shane. You'll be translating to the FSE and stowing your PGT on the tower handrail.
Oh, doesn't want to stay closed again.
Copy. We're seeing that, Shane. We're talking it.
You want to stay here? Yeah, nothing blocking it.
Yeah, copy.
When Pesquet arrives at the site upon which the solar arrays are located on the flight support equipment that carried them to orbit in the trunk of the Crew Dragon that SpaceX launched to the station back on June 3rd, he will use a pistol grip tool, a high-tech screwdriver basically, to release bolts that are called outer hinge restraint bolts, holding the array in question that will be the subject of today's installation for the 2B channel power augmentation for the International Space Station. Kimbrough, meanwhile, will translate outboard to the P6 truss to await Pesquet carrying the solar array that will be installed on the P6 truss over to him after Pesquet affixes an articulating portable foot restraint to the end of the Canadarm2 robotic arm.
And Shane, from what we see, it's holding well now. Do you think if you were to translate outboard, it would stay where it is? Looks pretty good to us.
Yeah, it looks good to me. I can't tell where it's attached or not, but it looks solid.
Copy. All right, Shane, you can start your translation out to the FSE.
Thanks.
Stand by, Shane. It looks like the thermal cover just opened.
Okay. Standing by.
Okay, Jenny, my crew lock back is stowed. So I'll be ready for your PG steps.
Copy, Thomas. You can ready your PGT. You'll be working on the outer hinge restraint bolt R5.
Shane Kimbrough continuing work to try to close and secure the outer thermal hatch cover over the crew lock section of the Quest airlock before he begins his journey out to the far left section of the truss of the International Space Station. Thomas Pesquet making his way to the location where basically the carrier holding the first pair of iROSA ISS Roll-Out Solar Arrays is located.
Jenny, it's closed again, and it seems to be holding for now.
Copy, Shane. We're having a discussion down here about whether we want you to put a tether on it. That's the holdup. So I'll have word for you on that soon.
Okay.
Jenny, I have my PGT and I'm ready for settings.
Bravo 2, counter 2.
Bravo 2, counter 2.
Good words. And Shane, we're going to have you put an adjustable equipment tether on the thermal cover to the circular handrail just to keep it closed.
And work.
Jenny, I have Bravo 2, counter 2.
Copy. Those are good settings. You'll be releasing R5, 18 to 20 turns. The bolt will spring out when fully released, and we'll be checking for a release indicator ring.
You're releasing R5, 16 to 20 turns.
A-firm.
I get low torque on the PGT, Jenny.
Say again, Thomas?
I get low torque on the PGT. I'm at 10 turns.
Copy.
I got 17 turns. See the bolt stopped out. I'll give it a couple more turns if you'll allow me.
Copy, Thomas. Checking.
All five is released. Jenny.
Copy, R5 released. And Shane, we recommend not wrapping the adjustable too tightly around the thermal cover. We just want a simple hook on it to keep it pretty much closed, but we don't want anything that's going to be too difficult to undo if you have to get in there quickly.
Okay, copy.
Shane, we recommend hooking to the loop, which is by your right hand on the circular handrail. That looks like a good point if you like.
Copy.
And Thomas, with R5 released, your next step is going to be to stow your PGT, the red one.
Jenny, if you have words for me, I think I'm doing a socket swap, correct?
A-firm, that was a handover, guys, so I'm back with you now. Your next step, Thomas, is to stow your PGT on the tower handrail, and then we have you putting the socket on Shane's PGT. But we're talking next steps since we're having Shane troubleshoot that issue with the thermal cover.
Okay.
Okay, Jenny, that's adjustables on there, complete.
Copy, Shane. We're still getting your helmet cam back with us after the handover, so we'll get eyes on that adjustable shortly.
Okay. You need me to face it, Jenny, or you guys are looking at other stuff?
They're talking at Shane. Word shortly.
My PGT now is a red going to NRASIO 13 on the tower.
Copy, Thomas. We'll have next steps for you shortly. And Shane, we're taking our time here because we want to make sure that we're really in a good config. So we're going to have you tether it such that the tether point that you're using is far from the hinge on the thermal cover. So at the actual opening, so toward your left.
All right. I'll move it over there.
Copy. Thanks, Shane. That'll be using that hook right by your left hand. And that's not the correct hook, Shane. We're looking for the hook, which is by your right hand, to move to the hook on the circular handrail near your left hand.
Oh, okay. Gotcha. Gotcha. Wanted me to move the whole thing. I'm sorry.
No problem. We're on the right track.
With Thomas Pesquet having arrived at the work site where the ISS Roll-Out Solar Arrays are located. In this view from his helmet camera, high-definition view, Shane Kimbrough now working to tether down in place the outer thermal hatch cover on the Quest airlock that has been a bit bulky this morning. 35 minutes into the spacewalk, Pesquet will begin to set up shop to release an outer hinge restraint bolt that will free up the solar array that will be extracted, that he will haul over to the P6 truss and ultimately hand off to Shane Kimbrough in a choreography that will ultimately result in that array being installed on a modification kit, a bracket basically, at the mast canister base of the P6 truss of the arrays, and then ultimately unfolded once a series of other bolts are released to enable the tension-laden solar array to unfurl.
All right, big picture for you two. We're having Shane translate out to the FSE, and he's going to drop his PGT there. Thomas, you'll be putting a socket on that PGT to continue with the anti-rotation device removal, the ARDs, so you can ready the 7/16 12-inch socket.
All right, 7/16 12-inch socket on Shane.
Thomas, we're going to have you stand by.
Standing by, Jenny.
Hey, Tom, I'm on phase 1, coming your way.
Okay, I see you from distance. Been good.
And ground copy, Shane.
And Jenny, you're breaking up.
Copy, Thomas.
Oh, now you're coming in clear.
All right, keep me updated on it.
I will.
And tomorrow, we're just keeping an eye on your Medox, wanting it to come down a little bit, which is why we had you stand by for a little while. We're pushing with the nominal timeline now. So we're seeing your Medox return to a good level now.
Okay, sounds good. Thanks for keeping me honest, Jenny.
No problem. Shane's around three minutes or so away.
Yeah, I see him coming. in between the two iROSAs.
Nice.
Beautiful sight.
There's a good view of Thomas Pesquet at the flight support equipment carrier, if you will, in which the first pair of ISS Roll-Out Solar Arrays are housed. He will begin work very soon to begin loosening bolts and anti-rotation devices, as they are called, basically launch constraints that held the arrays in place when they were launched back on June 3rd in the trunk of the Crew Dragon cargo vehicle that SpaceX launched on a Falcon 9 rocket from the Kennedy Space Center to bring to orbit. Those arrays arriving at the space station on June 5th and then robotically removed from the trunk of Cargo Dragon and mounted at that payload attachment fixture for the time being, awaiting the start of today's spacewalk. In the foreground is the trusty Canadarm2 robotic arm that astronaut Megan McArthur will be operating a short time from now to move Thomas Pesquet to the P6 work site as he carries the arrays manually, the first solar array, to hand off to Shane Kimbrough before it is mounted on a bracket at the base, at the mast canister base of the P6 solar array structure.
All right, I got your tether in front of me here. I'm just at the starboard seat of carts. Copy?
Ground copies.
Your feet there, Thomas.
My feet. Nice.
All right, port seat of cart coming to you. What do you want me to do tomorrow? Come up there? And
yeah, if you can. I'll try to come your way and meet you halfway. I have to bring the socket caddy.
So Shane,
it's attached to the bag.
Shane, you just need to get your PGT to Thomas. We have the published steps to stow it on the tower handrail, but if you can pass it to Thomas more easily, that's fine with us.
Yeah. I think that's what we'll try and do.
Just stay there, Thomas. I'm on the pallet now, too.
Okay.
I'll just come to you.
Okay.
Good with that?
Yeah, I'm good with that. Let's be gentle.
Nice and smooth.
All right, we put down a local tether.
All right, I've got a local tether down.
That's on a PGT. Have the PGT.
There you have it.
Gonna retrieve yours. Nice.
Got it.
Thank you. Thanks for the visit. Come back anytime.
All right, let me move slowly off of here, and I'll let you know when I'm clear.
Yeah, I'll wait for you to be gone before I move.
I'm just going to back out the same way I came. Still on. Clear? No? Okay. Rearrange here.
"45 minutes into the spacewalk, Shane Kimbrough and Thomas Pesquet are at the flight support equipment structure, holding the first pair of ISS Roll-Out Solar Arrays that were launched a couple of weeks ago aboard the SpaceX Cargo Dragon vehicle to the International Space Station. Each one of these arrays weighs 750 pounds of mass, of course weightless in orbit. Each new solar array will produce more than 20 kilowatts of electricity, eventually upping the power capability of the station by some 120 kilowatts. This is the first of 3 pairs of these arrays that will be installed at various truss structures of the station. Today and on Sunday, in the second of this first set of spacewalks, the 2B and 4B power channels of the P6 truss will be augmented by these arrays. They do not replace the older legacy solar arrays. They simply augment the power output of the existing arrays. The next 2 sets of arrays will be installed on the P4 and S4 trusses, and then ultimately the final pair on the S6 and S4 truss structures of the International Space Station. 6 of the 8 power channels on the station to be augmented. Those are the channels that have indicated the greatest set of degradation over the course of some 2 decades of use at the International Outpost, and also accommodate the highest usage loads for various payloads and scientific experiments and new modules to arrive at the International Space Station.
So those are your warnings. Your cautions are: avoid contact with the deployed and stowed radiators, and the battery adapter plate cables on the IEA are a snag hazard.
Okay, copy that. Thank you.
Shane, you're translating outboard to P6. I'll check your gauntlets are down, and I have a green hook location when you're ready.
Okay, gauntlets are down and ready for the green hook location.
P6, handrail 5312.
P312, copy P6.
And Jenny, I have the 7/16 12-inch on the green PG2.
Copy, and I'll take a pull test.
And I have a good tool test on that socket.
Excellent. Next steps for you, Thomas, are to start releasing the anti-rotation devices. So I'll have you translate to the Charlie 1 bolt, which is zenith and outboard.
Translating to the Charlie 1 bolt, zenith, and outboard.
Affirm, that'll be stanchion Charlie.
Copy stanchion Charlie.
Thomas Pesquet will be attaching an articulating portable foot restraint at the end of the Canadarm2 robotic arm that he will ultimately plant his feet in to be driven by astronaut Megan McArthur, who will operate the arm from a robotic workstation inside the station. He will carry the first ISS Roll-Out Solar Array over to the P6 truss, where Shane Kimbrough will set up another articulating portable foot restraint, so he has stability in receiving a handoff of that array from Pesquet at the appropriate time.
To attach an adjustable equipment tether to the ARD tether point.
And the green hook is on 5312.
Copy, Shane. You can translate outboard to P6 with 18.
Jenny, I have an AT on the ARD tether point.
Excellent. Thomas, your PGT settings when you're ready for them. Bravo 3, counter 2.
Bravo 3, counter 2. Copy.
Pesquet using a pistol grip tool. He will use it for about 18 to 20 turns until a outer hinge restraint bolt is released. That essentially is the first step in freeing the first ISS Roll-Out Solar Array from its flight support equipment that it was launched on.
Obviously, you guys can see that it's nighttime. Just a reminder to adjust your visors if you need to.
Copy.
Got Bravo 3, counter 2, Jenny.
Good words. You'll be releasing the stop block bolt, 10 turns only.
Copy. The stop block bolts called AR1, 10 turns only.
Affirm.
3, 4, 5. Ten turns.
Copy, 10 turns. You can release the ARD.
Jenny, I got 12 o'clock. Black on.
Okay, release the ARD.
Sorry, Jenny, 12 o'clock on the APFR and with 18. Black on black, good pull test, good twist test. I'm going to work on the settings now. That's right.
Copy, that's a good install. Clocking of 12. We're looking for Fox, Fox, Fox 4.
That's Shane Kimbrough installing his articulating portable foot restraint at the P6 truss work site. That will be the place where he receives the array from Thomas Pesquet once that array is freed from its flight support structure.
And Thomas, when you have a minute, we'll get you to power cycle your HECA as well.
Standby.
Jenny, this pit knob is really stiff. Any ideas?
Checking.
Okay, I got the ARD. We'll bring it back to my nailer station.
Copy, Thomas. The mini workstation end effector might be useful here.
Okay, I got the audio on my mini workstation. You wanted a power cycle of the ECA?
Affirm.
ECA off. Green LED.
I got the pitch now.
Okay, copy, Shane.
And maybe to retorque the ELD bolt and if you have settings.
Your settings are Bravo 1, clockwise 2.
Bravo 1, clockwise 2.
Good readback, and we're looking for turning this bolt to torque, like you say, expecting around 10 turns.
Copy, 10 turns.
Shane, once you have those APFR settings in, we're looking for a check that the pitch knob has popped out, and you can retrieve the cable bag bundle.
Okay. Working on the cable bag, and then I'll finish up the APFR settings if that's all right.
Copy, no problem.
Then you have green light, 11.9 on the torque. I only have 5.5 revs. But I think maybe you see my ECA, it's because the stop block has rotated a little bit. And now it's pushing against the bolt of that, the base of that extension that holds. So there's kind of a 6 millimeter difference from where it was before when it was flush against the beam. Does that make sense?
Yeah, I follow what you're saying, Thomas. We're checking on that, but for now I copy the torque of 11.9, a green light, and like you said, 5.5 turns to torque.
All right.
And Thomas, we talked that turn count down here. We're comfortable with you moving on in the procedure for now, so you can stow your PGT and translate to Charlie 2, which is Zenith and inboard stanchion Bravo.
Copy. Going to PG. 2. How are you doing, Shane?
I'm good. I'm finishing up the APFR. Got the crew light, or the cable bag. I'm on PRT now, and final settings here.
Awesome.
As we approach the 1 hour mark into today's spacewalk, Thomas Pesquet, in this view from his helmet camera, continuing work with a pistol grip tool to free up a series of bolts that essentially were launch restraints for the first of the iROSA or ISS Roll-Out Solar Arrays, as they were housed in the trunk of the Cargo Dragon vehicle that SpaceX launched to the station 2 weeks ago.
Which knob is popped up?
Copy. That is a good config, Shane. You can translate outboard to handrail 5307, where you'll be stowing the cable bag.
5307, copy.
Shane and Thomas, we're around 30 seconds from handover. I'll be back with you after that.
Happy journey, thanks.
Copy.
We're back with you after handover.
Hi, Jenny. I have the free hook from my AT on my main workstation is now on the ARD.
Copy, Shane. Your end effector is still on the ARD?
Oh no, Jenny, this is Thomas. The free hook of my AT that was on my main workstation is now on the ARD.
Copy.
ARD2 at Charlie 2.
The ARD that you're hearing referred to is the acronym for an anti-rotation device. This is a feature on the flight support equipment holding the iROSA or ISS Roll-Out Solar Arrays in place. That is essentially a launch restraint that needs to be removed prior to Pesquet using his pistol grip tool to break torque on the bolts that are holding the first of these two arrays in place.
Copy. We just wanted to triple check there. We understand, Thomas, that you're readied to the ARD on Charlie 2 and you're ready for your PGT settings.
Is correct.
Thomas, your settings are Bravo 3, counter 2.
Bravo 3, counter 2.
Good read back. And Shane, you'll be stowing the cable bag on handrails in that corner of the IEA around handrail 5307. Make sure that you position the hinge ISS inboard.
Copy. Working on that. So we got two tethers down, working on the third now.
Copy.
Jenny, I'm ready for 10 turns on the ARD bolts.
A-firm, 10 turns only. That'll release the ARD.
You try SSC 13, that's in node 2. Thanks.
Again, Pesquet right now using a pistol grip tool to release what is called an anti-rotation device. This is the mechanism that must be removed prior to breaking torque on the bolts holding the iROSA array in place on its flight support structure on the truss of the International Space Station. Meanwhile, Shane Kimbrough is out at the P6 truss stowing a bag of power cables on a handrail that will be used later in the spacewalk by Kimbrough and Pesquet to electrically connect the new array to the power system of the International Space Station.
I'm getting my crew lock bag out, and I'll head to the work site.
Copy. And Shane, we're also looking for a glove inspection, hap check, and gauntlets check from you.
Okay, white glove, no change, looks good. Left glove, no change, looks good. Dry hap, and gauntlets are down.
Copy, those are good checks, Shane. When you have the crew lock bag, you can translate to the left mod kit. I have some cautions for you when you're ready.
Okay, go with the cautions.
Standby 1, Shane. I see your ARD is released as reported. Thomas, your PGT settings to drive this stop block bolt to torque are Bravo 1, clockwise 2.
So ARDs released. There's a lot of friction on those ARDs. It's the same for both. This is a spec.
Copy, a lot of friction.
And then can you give me those settings again, Jenny? Please.
Bravo 1, clockwise 2.
Bravo 1, clockwise 2. Copy.
Cautions for you, Shane. No sudden movements on the mass canister or mod kit. We'll have you translate slowly and avoid cyclic loading.
Copy all.
You'll be stowing the crew lock bag on the left lower strut handrail closest to the mounting bracket, the lower handrail stanchion.
Yeah. And then you have a good torque, 12 turns, and torque, sorry, 9.6 turns, and 12.0 torque in good green light.
Copy, green light, 12 on the torque, and 12 turns. Thomas, you can stow your PGT, and then we'll put you back to the crew lock bag to stow those ARDs, retrieve the scoop, and do a socket swap.
Bring the PGT in back to a crew lock bag.
Good words, Thomas.
How's that bag, Shane?
What's that?
How's that bag?
Oh, it's good. We got the crew lock bag out now, working on that.
All right.
Ground copies.
Okay, Jenny, I'm back at the crew lock bag, and I'm getting ready to stow the 2 scoops on the 3 reds out of the crew lock bag. I mean, the 2 ARDs.
Copy. Those are good words, Thomas. You'll also be retrieving the scoop with the long-duration tie-down tether and stowing that on your mini workstation.
Copy.
This is Mission Control Houston, 1 hour, 12 minutes into today's spacewalk by Thomas Pesquet and Shane Kimbrough. The 2 spacewalkers are working in the very, very early stages of their respective tasks that will result in the removal of the first iROSA Roll-Out Solar Array from its flight support structure.
Tether on it.
You can see in this image that large support structure that was housed in the trunk of the SpaceX Cargo Dragon vehicle that carried it to orbit back on June 3rd when it was launched from the Kennedy Space Center, arriving at the International Space Station 2 days later.
Make sure it stays redded to the crew lock bag, and you'll install it with the handle pointing inboard.
Gotcha. Copy.
Pesquet next will use a pistol grip tool to break torque on 2 bolts on that flight support equipment structure holding the iROSA array in place. Shane Kimbrough is still working in the final steps of setting up shop at the P6 truss with an articulating portable foot restraint that he will be awaiting the arrival of Pesquet in. Pesquet will set up a foot restraint of his own at the end of the Canadarm2 robotic arm, and then place his feet in that foot restraint, pull the array out of the flight support equipment structure, and haul it over to where Kimbrough is for a handoff. Kimbrough will then rotate that array in the proper orientation to await Pesquet's arrival so that the 2 crew members can work with each other for the ultimate installation of that array on a modification kit, essentially a bracket that was installed at the base of the mast canister of the P6 truss array structure on a previous spacewalk.
Okay, I see the micro square here.
Copy, Thomas. Yeah, we see that in your WVS. Make sure that you have the scoop with the long-duration tie-down tether, which you do, and that goes in on your mini workstation.
That was shared, Jenny, but I'm working on this.
Copy.
Okay.
So then, Shane, I copied
All right, Shane, if
you have the scoop, which is staying ready to the bag, and you're going to be installing it on the root beam microsquare.
Jenny, and I have the scoop. With the long duration on the crew lock bag. Put that on my mini workstation.
Copy, Thomas. Following that, we'll have you do a socket swap.
Okay, this is on my mini workstation. And socket swap to 5/8.
That's exactly right, Thomas. We're looking for the 5/8 12-inch socket on the PGT.
Copy. 5/8 12-inch socket for Shane.
Okay, Jenny, the square sweeps install handle is inboard.
Copy, Shane. That's a good config. You can get started on routing the right wire harnesses from the cable bag. Let me know if you need additional words on running to them or routing them.
Okay, copy that.
Jetting the 7/16, 12 inches back on the socket caddy is a good pull test, working on putting the 5/8, 12 inch on Shane's PG.
I copy a good pull test on the 7/16 12-inch on the socket caddy, and you're working on the 5/8 12-inch on the PGT.
That is correct. Alright, the 5/8 12 inch is on the PGT with a good pull test.
Copy, good pull test on the 5/8 12-inch on the PGT. Your next steps, Thomas, are to break torque on the iROSA FSE bolts, Charlie 2 and Charlie 1.
Copy.
Jenny, I have a ret on the red cables. So I'm going to release the ret from the back and then take them up to the live kit right side.
Copy, Shane. That's a good config. And Thomas, while you're buttoning up this crew lock bag, I just wanted to let you know that occasionally your comm is coming through muffled. I understand there's not much that you can do about that at this point. Your mic booms are set, but that's why I'm repeating calls back to you, and just correct me if we ever get it wrong.
Yeah, that sounds good, Jenny, and I'll try to be clear. And Shane, do you copy me, or is it the same for you?
No, I'm copying you good.
Okay. Copying you good, too.
Copy all.
And you're sure it's not my French accent that's throwing you off? You're Canadian, you can handle it. All right.
Thomas, you'll be translating to Charlie 2 to break torque.
Copy, Charlie 2 to break torque.
A-firm, that's Zenith, and inboard or stanchion Bravo.
Spacewalk communicator Jenny Seide, a Canadian Space Agency astronaut, talking to Thomas Pesquet as he uses a pistol grip tool to break torque on a pair of bolts holding this first iROSA Roll-Out Solar Array in place on its flight support equipment on the truss of the station. A distinct Canadian flavor to today's spacewalk, with Saidi talking directly to the two spacewalkers outside. Next to her is veteran astronaut and veteran spacewalker Drew Feustel, who was educated, amongst other places, at Queen's University in Kingston, Ontario, Canada. The space station's robotic arm, the Canadarm2, will be used to move Thomas Pesquet, holding the iROSA solar array, over to Shane Kimbrough, where they will work in concert with one another to install it at the mast canister base of the P6 solar array truss structure. The P6 truss arrays were delivered to the International Space Station on the STS-97 mission aboard the shuttle Endeavour in December of 2000. That also featured the presence on board of Canadian Space Agency astronaut Marc Garneau, the first Canadian to fly in space.
Thomas, now that you're at Charlie 2, let me know when you're ready for PGT settings.
Okay. Jenny, I'm at Charlie 2, Shane's PGT, degrade PGT, 5/8 times 12 inches, and I'm ready for settings.
Copy. You're in a good config, Thomas. Your settings are Bravo 3, counter 2. You'll be releasing Charlie 2, less than half a turn.
Bravo 3, counter 2, less than half a turn.
Affirm.
Okay, less than half a turn on Charlie 2.
Copy. Half a turn on Charlie 2. You can stow your PGT and translate to Charlie 1.
Copy, stowing and moving on to Charlie 1. How you doing, Shane?
Good. I got the first cable tied down and just looking at the distance before I do 3 turns on it. But good.
Nice. Nice work.
Ground copy, Shane.
The second one, I found I have to move out quite a bit. So, got a red on that and undo it.
This is Mission Control Houston, approaching the 1 hour, 30-minute mark into today's spacewalk. A good view of European Space Agency astronaut Thomas Pesquet by the flight support equipment, and you are getting a great view of the two pairs of folded ISS Roll-Out Solar Arrays, one of which will be extracted from that flight support equipment a short time from now and moved by Pesquet at the end of the station's robotic arm over to hand off to Shane Kimbrough at the P6 truss of the station, where it ultimately will be installed and mounted in place for its deployment later in today's spacewalk. The International Space Station is flying into an orbital sunrise over the Pacific Ocean, soon to cross the coast of Mexico, flying 258 statute miles above the Earth in an orbit inclined 51.6 degrees to either side of the equator, this track carrying it from southwest to northeast.
Jenny, I'm in position for Charlie 1.
Copy. You'll be braking torque on Charlie 1, less than half a turn. Let me know when you're ready for settings.
Braking torque on Charlie 1, less than half a turn. I'm ready for settings.
Bravo 3, counter 2.
Bravo 3, counter 2.
Good read back.
In work. Less than half a turn on C1. So, let me do that again. I got low torque. Torque of 9.4 for 18.4 is not great. Moved by less than half a turn, but you want me to give it a little bit more, Jenny, or not?
Checking, Thomas.
Okay. And I saw it moved then by less than half a turn.
Yeah, we're happy with that, Thomas. As long as it moved, we're just braking torque at this point.
Okay. Thank you.
So now you'll be releasing Charlie 1 27 turns only, and I have new settings for you.
Copy. 27 turns on Charlie 1, and I'm ready for settings.
Bravo 3, counter 3.
Bravo 3, counter 3. And Jenny, I just saw that my PGT in counter 1, so maybe it skipped when I had to set it to counter 2 before. It seems like I turned Charlie 1, but I'm counterclockwise 1, I think. Braking torque. Need to go back at counterclockwise 2?
I'm checking for you, Thomas.
Thank you.
Thomas, you can continue. Again, we just wanted to brake torque there, so as long as the bolt moved, we're happy for you to press.
Okay, perfect. So Bravo 3, counter 3, correct?
Affirm, those are good settings. You'll be releasing Charlie 1 27 turns only, so not fully released.
Copy, looking for 27 turns on Charlie 1.
Good read back.
You need the right side cables are done. I'm going for the left ones now.
Copy, Shane. The right wire harnesses are complete. You are moving on to retrieve the left ones.
Correct.
Ready at 27 turns on Charlie 1.
Copy, 27 turns on Charlie 1. You can stow your PGT, and we'll have you translate back to Charlie 2.
Copy, stowing the PGT and back to Charlie 2.
A great view of Thomas Pesquet using his equipment to break torque on a pair of bolts holding the iROSA solar array in place on its flight support equipment. Meanwhile, Shane Kimbrough at his work site at the P6 truss of the station, the far left side of the backbone of the station, is routing a series of harnesses that will be associated with the power connectors that will hook up the electrical connections for the new solar array to the power system at the mast canister base of the solar array.
Jenny, I got a ret on white cables in cab side. I'll release the ret from the pad.
Copy, Shane. Shane, Thomas, I'm back with you after a handover. I copied the RET config for the wire harness for Shane.
Jenny, I am ready for settings on the PG for Charlie 2 for turns.
Bravo 3, counter 3.
Bravo 3, counterclockwise 3.
Affirm, and you'll be releasing Charlie 2, 51 to 54 turns. The bolt will spring out when fully released.
P51 to 64 turns, copy. On Charlie 2.
Affirm.
As we hit the 1 hour 36-minute mark into the spacewalk, this view from Shane Kimbrough's helmet camera, he and Pesquet and the rest of the crew members on the International Space Station are crossing the coast of Mexico north of Guadalajara, orbiting 258 statute miles above the Earth. Pesquet using a pistol grip tool to break torque on a pair of bolts holding the ISS Roll-Out Solar Array in place on a flight support cradle that was delivered to the station with the first pair of solar arrays on the SpaceX Cargo Dragon vehicle 2 weeks ago. Kimbrough, meanwhile, is routing a series of cables that will ultimately be used to hook up electrical connections between the new array and the electrical ports at the base of the P6 solar array truss structure.
Actual was 6.9. At the end, it was very, very low torque. It was higher at the beginning.
Okay, Thomas, I copy Charlie 2 released with 57 turns. You can stow your PGT.
Copy, stowing your PGT. Again, Jenny, as a piece of data, the first 10 turns where I could tell the torque was really high, and then it kind of moved a little bit, and then the rest was really easy.
Okay, we copy, Thomas, the change in torque you felt when you were releasing that bolt. Thomas, your next step is to install the scoop on the root beam microsquare near Charlie 2.
Copy, installing the scoop on the root beam microsquare at Charlie 2.
Affirm.
Yep. And
remember that scoop is going to be installed at a 45-degree angle toward you.
Copy, 45-degree angle.
Jenny, I got the first cable wire tied down. I'm going to have to move the second one. I'm just like the other one, so give me a minute here.
Copy, Shane.
And Jenny, that scoop is at a 45-degree angle. I'm going to take my rod back. And it's secured in place.
Copy. We can see that. It looks good. Thomas, you can release your rut.
Okay, and I'm going to go back to the other side, Jenny, if that's correct.
Affirm.
Both sides.
That is right, Thomas. You are headed back to the tower handrail, where you will swap PGTs. So stow Shane, retrieve yours, and then I'll take a glove inspection half check.
Good. the cable, Shane?
Just moving this wire tie again, and then I'll tap this one down and we'll be good to go.
Jenny, I have a Shane's PGT with the 5/8 12-inch wobble socket on handrail 0013 on the tower, and I'll go ahead and retrieve my rod from that PGT.
Copy. Good words, Thomas.
Jenny, the are down with 2 wire ties on the mid-strut handrail, one on the lower strut handrail.
Copy, Shane. 2 wire ties down for the left wire harness.
Do a little cleanup here before I head back.
Shane, before we do anything else, heading back inboard, we want you to check that the soft capture features are armed and down.
Okay, the one in right in front of me, the left one is not, so I'll put it there.
Copy.
Shane Kimbrough at the base of the P6 solar arrays that were delivered to the International Space Station.
Just a little bit of sticking up.
The first set of solar arrays to arrive at the station back in December of 2000 on the STS-97 mission aboard the shuttle Endeavour.
Verified that the strut MLI is clear for iROSA install.
Okay, strut MLI. Yep, it's well below the plane there, so I think we're good.
Copy, Shane. It looks like the mounting bracket is in a good config. So with that, I will have you head inboard, retrieving your green hook on the way.
Okay, I'm going to tie up this screw lock guide a little bit better, and then I'll be heading back.
Copy. That sounds good.
And Jenny, I have my PGT on the 9 walk station, and Shane's PGT on the handrail to the right.
Copy, Thomas. That's a good config. I'll take a glove inspection and a HAP check.
Okay, gloves are good, no change, absolutely no damage whatsoever, and the HAP is dry.
Copy, no change to your gloves and a dry HAP. You can move on to SSRMS setup steps, which has you first translating to the starboard seat of cart.
Copy, inward translating to the starboard seat of cart.
1 hour, 46 minutes into the spacewalk, Pesquet has released These two bolts holding the iROSA solar array that he is just behind on its flight support equipment structure. Two bolts that he used a pistol grip tool to release. Next up for Pesquet will be the setup of an articulating portable foot restraint at the end of the Canadarm2 robotic arm as the International Space Station passes just over the capital of Canada, Ottawa.
Copy, Shane.
It looks like you'll have time here, Shane, because I'm not in the APFR yet.
No worries. Long ride.
The ISS Roll-Out Solar Arrays, the iROSA. This is a new design that uses a one-piece carbon fiber composite boom that is essentially folded up into halves. Those two halves will unfold at the hinge. A bolt holding that hinge in place was released earlier in the spacewalk by Pesquet. This enables stored energy on the two halves of the boom to actuate the deployment sequence later in the spacewalk.
Hi, Jenny, I'm at the CEDA cart. Forward CEDA cart, I see the APFR in width 5, which is the medium-most one.
Good words, Thomas. That APFR should have an ingress aid. You're to retrieve it and translate back outboard.
Copy.
Pesquet again about to set up a portable foot restraint at the end of the Canadarm2 robotic arm that will be operated inside at a robotic workstation by Megan MacArthur. She will drive the arm with Pesquet at the end of it. He'll be holding the iROSA solar array and will bring it toward Shane Kimbrough, who's awaiting its arrival at the base of the P6 solar array truss structure after routing two sets of wire harnesses that house connections, electrical connections, that will hook up the array to the electrical system of the International Space Station's 2B power channel.
Okay, I have my BRT rep on the APFR tether point.
Copy, Thomas.
I have the APFR. Throw it on my BRT. Okay, J5 on my BRT, and I'm making my way back to the FSE.
Copy, Thomas.
I'm here at the port Cedar Cart, Thomas.
Hi, Shane.
And so you want me to wait on you?
So Shane,
I don't go back to the FSE.
Shane, you can translate.
Go to the FSRNS.
You can translate to the FSE. You'll be at the grapple tower, and Thomas, you're actually just translating to the port Cedar Cart, where you'll give SSRMS a go for the install position.
Yeah. Right.
All right, sounds good. Okay, I'm on the FSE.
Copy, Shane. Shane, I'll take a glove inspection and a HAP check from you, and then we're talking about next steps.
Okay.
Okay, I'm at the port Cedar Cart. Which I'll stay away from.
I'll see you there, Thomas.
Okay.
My safety tether's just on your back of your plus.
I'm sorry, what?
My safety tether's on the back of your plus, but you're okay right now.
Okay, it's going up.
There you go. Nice.
Okay.
I have a big picture update for both of you when you're ready.
Ready?
Ready?
Okay, so the next steps for Thomas are going to be to configure the arm. That means that we have about 20 to 30 minutes before we're ready for release from the SSE, which, Shane, are going to be your next steps per the nominal timeline. So we're polling you two on how you would feel about get-aheads on the R bolts on the lower iROSA for Shane at this time, while Thomas, you push with the arm reconfig and the nominal R bolts for the upper iROSA.
And Jenny, is it something that we can break out at any point and leave the iROSA in whichever intermediate configuration we're in, or do we have to get to a certain point with those get-aheads?
We can break out from those R bolts at any time.
Yep, same as usual.
I need about 5 minutes here to reconfigure my waist tether. So once I'm done with that, I can do whatever. But,
Okay, copy. That sounds really good to us. And
Jenny.
there is no rush. You take your time, Shane, to configure your tethers, and Thomas will push with your nominal steps. Shane, let me know when you're ready.
okay, better.
That sounds good. And I'll be ready, Megan, if you're with us. Megan and Mark, I'll be ready for the maneuver to the HFR install position.
Okay, Thomas, Megan's ready as well. This public position would be 50 centimeters station zenith. Do I understand correctly that you're go for GCA, or should we wait for other comms?
No, go for GCA, and I think Shane is happy to come here for now.
Okay, let's start GCA. Bring motion.
Good motion.
Good motion. Centimeters to publish.
Continue.
Centimeters.
Continue motion.
5.
We can stop motion.
Okay, I heard you say stop motion. Is this a good position?
If you can give me maybe 10 to 15, or let's say 20 station aft, sorry, and 20 more station zenith.
Is it okay if we go with the zenith first? So 20 more station zenith?
Yeah, 20 more zenith is fine.
Starting motion.
Station zenith.
Copy. Starting motion.
Good motion.
Good motion. 5 to go.
Good position, stop motion.
Copy, stop motion, and you wanted 20 centimeters station aft, was that correct?
That is correct.
Motion.
Good motion.
Okay, good motion.
And stop motion.
Motion.
Okay, that's a good position. GCA complete.
GCA complete. Brakes are on, go for APFR install.
Copy, go for APFR install.
Thomas, we understand brakes on. You do have a go to install that APFR. Let me know when you're ready for settings.
Copy, go to install the APFR. 5 minutes for settings.
And Shane, when you have a spare minute, understand you're working with your tethers now. Could you please power cycle your HECA?
I got a green light now.
Copy.
And Jenny, I'm ready for settings on the APFR.
Looking for an install, clocking of 12.
Give me the rest. Can you go ahead with the rest of the settings, please?
Papa Papa, Fox 6.
Papa Papa, Foxtrot 6. Copy. The clocking of 12. Okay, Jenny, I have 12, Papa Papa, Foxtrot 6, and sorry, I have Papa Papa, Foxtrot 6, I'm going to go ahead and install with a clocking of 12.
Copy, good words.
Jenny, I have a clocking of 12, I have a good full impact test, black on black, on the clocking color.
Copy, those are good checks, and let's ensure the pitch knob is popped out.
And the pitch knob is popped out. Actually, I haven't touched it. It was a Papa Papa.
Copy, that's a good config, Thomas. I can talk you through your safety tether swap to the SSRMS now.
Give me just 1 second.
Let me know when you're ready.
I will.
Okay, Jenny, I got my tether stuff figured out, so what the timing looks like.
Copy, Shane. The timing still looks good, so I'll get a glove inspection and a HAP check from you, and then I have your first get-ahead words ready.
Okay, left glove's good. Right glove, I have a little black smudge on the middle finger. See that? It's other with the no damage or anything. Looks like just a grease smudge or something.
Copy.
Dry hat.
Copy and dry HAP.
And Jenny, I'm ready for the search tether swap words on the SSRMS.
Copy, Thomas. First, you'll lock your green tether reel and check your green hook is locked.
Green reel is locked. And sorry, what was the other check?
Check your green hook is locked.
2 hours, 5 minutes into today's spacewalk, continuing to receive breathtaking views of Thomas Pesquet at the flight support equipment structure on the truss of the station, housing the first pair of iROSA or ISS Roll-Out Solar Arrays, one of which will be installed at the base of the P6 solar array truss structure this morning to begin the augmentation of power capability for the International Outpost. Pesquet is about to enter an articulating portable foot restraint he has attached at the end of the station's robotic arm, the Canadarm2. That will be operated by astronaut Megan MacArthur, who will transport Pesquet and the first of the two solar arrays over to Shane Kimbrough at the P6 truss to begin the installation of that array at the mast canister work site location at the base of P6.
she's attached to the port to the car medium handrail, and I'm going to go ahead and unlock my green reel.
Good words.
It's done.
I got a good eye on me there, Thomas, looking good.
And Shane, we're just finishing up with Thomas' tether swap at this time, but I can send you to the crew lock bag to retrieve the socket caddy. You'll be installing a socket on the spare PGT.
All right, that sounds like a lot.
And with that, I think we can move beyond to the ingress position. No, I'll have to extend the ingress aid. Yeah, let's do that now.
Thomas, understand you've attached your green hook to structure, unlocked your green tether reel, so that's right. Once comm is clear, you have a go to work with SSRMS to GCA to the ingress position.
Copy. And Mark, are you with me? Mark from Thomas?
Go ahead, Thomas. I was calling the wrong loop. We've got a published position 10 centimeters station forward and 50 centimeters station nadir, if that works for you.
That seems to be perfect. So with that, you can... Is that a GCA? I think it's a GCA.
Affirmative is a GCA. With that, we'll consider that start GCA.
That is a start GCA.
Sorry, first motion is 10 centimeters station forward.
Sounds good. That's a good motion.
That's a good motion. Okay, to my correction, we're going 70 centimeters station nadir.
Copy 70, and this is good motion station nadir.
It's a good motion.
I think it's stop motion here, Mark.
Good motion.
All right. Looks like I can enter the APFR from here without too many problems, so I'll call that GCA complete.
Copy, GCA complete. Brakes are on, go for APFR ingress.
Copy, brakes are on, go for APFR ingress.
Understand brakes.
Jenny to Shane, hey,
Understand brakes on. Thomas, I'm going to get you to attach your waist tether to the APFR, and then you are go for ingress. And Shane, I'm back with you. You're installing the 7/16 6-inch wobble on the spare PGT.
okay, and I was just going to call you and see about the timing because it seems like he's getting pretty close, but maybe I don't have a big picture.
Yeah, so big picture, I can fill you in there. We still have a couple of arm motions and also those bolts which require 245 turns. So those will take a couple minutes each. And since we can break out of doing the R bolts at any time, we still think it's worth getting one or two. But we're keeping an eye on things. Let us know if anything changes for you.
Okay, so I'm going to put this 7/16 6-inch wobble on the spare PGT, is that right?
That's exactly right.
Okay, so it looks like both heels are in. That's what it feels like. Now my waist saddle on the ISS Roll-Out, Jenny.
Copy. And if your tools and tethers are clear and your ingress aid is stowed, you can maneuver to the back-off position.
My ingress aid is stowed, tools and tethers are cleared. There's a Shane set tether here, but I'll try to keep it out of the way. And Shane, I don't know if you have a visual.
I don't know. I can be there in just a minute if I break out of this.
Just to have a look that your set tether is clear and everything's looking good. See the line here.
A good pull test on the 7/16 on the spare PCT.
Copy. Looking for a good pull test.
Pull test is good.
Copy, Shane. Good pull test.
Hey, Tomas, the way we see it on the arm is we've got to move you a little bit to get to a spot that'll still be a GCA because you're so close to structure. So we've got about 30 centimeters to do as a GCA, and then after that we'll just do a manual back-off maneuver.
Okay, that sounds good, and I would be nadir, right? That GCA.
Affirmative. Let me know when you want to start that GCA.
Prior to GCA, I'm going to pass instructions to Shane.
Go ahead, Jamie.
Thank you, Shane. You're going to be working near stanchion Bravo, which is inboard and zenith, and we're going to be releasing R5. And Shane, I can hold on settings for you until you're ready. We're about 20 seconds from handover as well.
Yeah, just hold off.
Okay. And but during the handover, I think we can start the GCA or not, if you agree.
We agree, and we're starting that GCA, 30 centimeter station nadir.
Copy, 30 centimeter station nadir.
Two hours, 15 minutes into today's spacewalk, Thomas Pesquet and Shane Kimbrough are working together on different tasks, but essentially it's all the same work to prepare for and conduct the release of a series of bolts for the iROSA, or the ISS Roll-Out Solar Arrays boom deployment system, and a launch restraint that is holding the boom in place on the flight support equipment pallet, if you will, that the arrays were carried up on during launch 2 weeks ago on the SpaceX Cargo Dragon vehicle. There are two bolts that must be released for the boom deployment restraint system. There is an additional pair of bolts that release an outer deployment restraint capability. Basically, they're freeing up the iROSA array, the first of the two sets of arrays carried to orbit, so that Pesquet can transport the first of the arrays over to Kimbrough at the P6 worksite for its installation on a bracket, or a modification kit, as it is called, that was erected and installed on the International Space Station on a previous EVA.
My hand. I have a view, it's better, but I think it's good.
I do not have a view right now.
Yeah, I think it's good, Mark. We can proceed. I have it right in front of me.
Okay, we're working on that. And we're starting motion, Thomas. We're going away from the station.
Good motion.
And just a reminder, this is not a GCA, so the comm is still open.
We
Mark.
agree. Shane, let me know when you're ready for PGT settings.
Closing out the backfill, just got the PGT on my workstation.
Copy.
Inside the International Space Station, NASA astronaut Mark Vande Hei has joined Megan MacArthur at the robotics workstation. MacArthur is the prime crew member to maneuver Pesquet from the flight support equipment housing the solar array over to the work site at the P6 truss, where Kimbrough is conducting some advance work for Sunday's second spacewalk in this series, in which the second of the two ISS Roll-Out Solar Arrays will be removed from its flight support equipment and maneuvered to the other side of the P6 truss to hook up to the 4B